Hey everyone, hope you're doing well. I'm Vahid. In this series of tutorial, I will help you to learn sheet metal bending in SolidWorks, which nowadays there are many opportunities in industries and it gives you a good chance to compete with other rivals. So without any further ado, let's go into learn this to start this series. Um, Unlike other tutorials, I would like to give you a brief introductions regarding the sheet metal, and after that, we can start the SolidWorks. Um, just consider that just going to be a brief introductions. For more understanding, it's up to you, and you can go and study by yourself. Sheet metal bending. The purpose of the sheet metal bending method is to shape a metal into its intended forms. Multiple factors play a role in deciding which sheet metal bending method is optimal for a given project. These factors include the thickness of the sheet metal, the bend radius, the overall size of the bend, and the desired use. It depends on the client what they want, and you as a designer you have to find the best thickness and how to separately design the sheet and then weld it together in order to find the best or the final shape you wanted. There are many applications from automotive industry to home appliances. If you look around yourself, you will see many things which has been made by sheet metal. Uh, First, I would like to talk about the K factor, which is very important in sheet metal bending. Um, the K factor depends on the several factors, including bend allowance, the thickness, the material. Um, By choosing the right K factor, you can find a right size of the flat sheet, which is really important. If you go into a wrong K factor, at the end that sheet is going to be bigger or smaller, or you find a gap between the bended areas, which makes it difficult for fabricator. Please bear in mind that go into the right K factor. It changes, the range of that actually is going to be between a zero point 0.3 to zero point 0.5. And on the bottom side, you will see a sheet metal which bended into the 90 degree. Um, and you will see the definition of the K factor, which is going to be the measured neutral axis shift towards the material thickness. By bending the one sheet, you will see that the area is going to be divided into the two different sections, compression zone and the tension zone. And the changes of the neutral axis towards the sheet metal thickness is going to be a K factor. On a different material is going to be different. For example, on soft material, usually choose 0.35, or for semi-hard material is going to be 0.41, and for the hard one is going to be more than 0.45. There are many sources which they represent different call factors based on the thickness or based on the material. Here I just wanted to show you one of them, which I got it from this website. You can go and study deeply by yourself. For example, here mentioned about the aluminum and the steel. For example, when you have a soft material or a medium material on a different thickness, you will see that the different K factor we will have. But I want to mention that two things, just bear in mind. Whenever your thickness is going to be higher, the K factor increases. Or when the yield stress goes higher, or whenever you have a hard material, you need to choose higher K factor. So this was a brief introduction regarding the sheet metal bending curve factor you need to understand before starting SolidWorks module. So let's delve into the SolidWorks. So to go first, create a new files, create a new part as well. So this is the module you will see at the beginning. In order to start the sheet metal bending, you can go towards the insert and find sheet metal. So the first things in the sheet metal is the base flange. You start your job by a base flange, but there is another way you can have access to the different comments here. So through this tab. But in this tab, we don't have a sheet metal. It's easy just to have a right click on this tab, go to the tabs, and then tick the sheet metal. See, you will see the sheet metal here. If you go towards the sheet metal tab, you will see different comments here. So let's create a base flange, which is going to be the first or initial of the sheet metal bending module in SolidWorks. When you click on that, it will ask you about choosing a right plane. Consider that we want to create something on the front plane. So here I just create one simple sketch, considering that I want to create something like this. I will measure it. After finishing, you just go out, select the sketch, and all of a sudden you will see the bend radius. You didn't put a radius at the corners, but here it shows you the radius. So this property manager pops up when you click the sketch. The first thing is the direction. So how much you want to extend this uh, sketch? It depends on you. For example, I want to increase the distance to 30 or 40 millimeters. You can extend the distance at both directions. If I check this, you will see that the sketch is going to be in the middle, and I can import different distances. The next thing which you have to change is the thickness. What thickness you want to choose. For example, here I want to choose the thickness 3 millimeters. And it gives you an option to reverse the direction. What does it mean? If you reverse the directions, you will see that the material is going to be inside or outside of the sketch. See? By tick this, you will see the preview on the screen. So I'll just leave it as it was. And the most important thing here is the bend radius you want to choose. For example, here depends on the function, and you are as a designer, you need to choose the right bend radius for your project. For example, sometimes you need to go towards a sharp end, like a 1, or even if you need a smoother surface, you can increase it, for example, to 12.5, and you can also ask this from the fabricator what tool they have, and based on the tool they have, you design the sheet metal. Here, I just put it as a 1. And the next thing is the bend allowance, sorry, which shows you the K factor. Uh, Here, consider that my material is aluminum soft. For the aluminum soft material, usually fabricators go into 0.33 or 0.36. From fabricator to other fabricators, it's going to be different, but normally I put it as 33. And another thing is the auto relief. Here we don't need that auto relief, which I will explain in the next tutorials. But we have 3 options for that. For example, rectangular, tier, or all round. So another options here is the sheet metal gauge. By ticking this, it gives you an option to choose the thickness based on a gauge, which is not the topic we want to talk. Maybe in the future I will talk about that more. So after changing this, you can click OK, and you will see the material bended. Consider that there are times you choose one K factor and you understand that you want to change it. So how you can change it? By creating this, you will see 3 different in your feature tree. So the first one is the sheet metal, the base flange, and flat pattern. If you right click on the base flange and go to the edit features, you don't see the previous values imported. You just see the distance, the thickness, and the radius. So if you want to change the K factor, you need to go towards the sheet metal, right click, edit features. Now you have an access to the K factor. From here you can change it. So this was the first or the initial step in the sheet metal beveling, which we started with the base flange. And today I want to conclude my tutorial with this. In the next tutorials, I will talk about the flange and other modules in this tab. So let's stay tuned with us for more tutorials. Thanks for watching us. Please subscribe us and send our tutorials to your friends.